Hi everyone. Today we're going to be talking about the first section in the textbook, which is section 1.1. Now hopefully this is a topic you've seen before, but I know it's been several months or years since you've seen this, so we're going to cover it again today. It's going to be kind of review. Anyways, let's just get right into it. So the goal today is to be able to find the distance and midpoint between 2 points. Now before we even get into what those things mean, I first want to just talk about graphing a point. Let's go all the way back to the basics. Now when I'm discussing a point here, what I'm really talking about is an ordered pair. We use those pretty much interchangeably, and essentially what we're talking about here is an XY ordered pair. X comes before Y because that's how it works in the alphabet. So let's just graph a couple of points. This will probably be the easiest assignment you do all year, so you should be thanking me. So 2, 1. We're going to go 2 on the x-axis, 1 on the y-axis, and there is my point 2, 1. This is also a really good chance to show you what I expect whenever you graph something. You need to make sure to label your x-axis and your y-axis no matter what. They might have different letters sometimes, but make sure you please label your axes. -3, 4, we'll go -3 on the x up to 4 on the y. I don't necessarily expect for you to label each and every single, let's use blue here, each and every single mark on the axis, but you should have them indicated and they should be equally spaced. So if you go up by 5s, 5, 10, 15, 20, that's fine, but they should all be equally spaced. And then the last one will be -5, -2. So we'll go over here to -5, go down to -2, and that's going to be my point there. So I have the point -5, -2. I have the point -3, 4. And I have the point 2, 1. Okay. Awesome. We graphed some points. Didn't that feel good? Now what I want to do is find the distance between some points. So I will come back to this graph. So hang tight on that. But we're going to come down here and we're going to figure out the distance between 2 points. So essentially, we're going to be using what's called the distance formula. But in this class, I don't like to just always give you formulas and not talk about where they come from. So first of all, I will do the distance formula, and then we'll actually show why this is the formula. So the distance formula is, use some words here first, the distance between 2 points, which we'll call point 1, we'll have an x with a little 1 next to it, x1, y1 for point 1, and the next one, x with a little 2 next to it. Hopefully that's familiar. If not, please let me know. So the distance between these 2 points is given as d equals. Now we're going to put a large square root symbol. When you do your square root symbols, please add one little detail that I'm missing from this. Make sure you put a little tick mark at the end so I know where your square root ends. Later on, this will be very helpful. I'll remind you of that later on when we get there though. Now under the square root, we're going to write x2 minus x1. We're going to square it, and then we're going to add y2 minus y1 and also square that. This is the formula. If you don't have this memorized at this point in your math career, you should memorize this. Write it down, circle it, star it, get it tattooed, whatever you have to do. Now I did promise I would tell you where this came from, so we're going to go back to that graph we just had, and we're going to use the points 2, 1, so we'll call this example, the point 2, 1 and the point, I've already forgotten, let me check here, we'll do negative 3, 4. So when I'm trying to calculate the distance, what I'm really looking for is the length of this line that connects the 2 points. Now, in order to figure this out, a long time ago, probably the Greeks, I'm not sure who did this, but someone said, hey, look, if I drop this line down to here and then I drop this line down to here, that actually looks like a right triangle. And luckily, some fellow named Pythagoras came up with something called the Pythagorean theorem. Pythagorean theorem. Which, as you all remember, tells me that one side squared plus the other side squared equals the hypotenuse squared. So we have, oops, sorry about that. We have usually A, B, and then the hypotenuse is the longest side, C. And so really what this comes down to is figuring out the length of this side, which you can see is 2 minus negative 3, or just 5. And then also the length of this side, which is 4 minus 1, which is 3. So I have A equals this and B equals this. And now if I plug that into my theorem, I end up with 5 squared plus 3 squared equals C squared. 25 and 9, I believe that's 34. Now you're going to see where that square root comes from. So C equals the square root of 34. And that would really be my final answer. Notice we also could have done this by saying, well, my distance has to be the square root of 2 minus negative 3 squared plus 4 minus 1 squared. We could calculate this. If I was doing this, I'd probably just plug it into a calculator if we're starting to get larger numbers. In this case, it's not too bad. We might say, well, it's the square root of 25 plus 9, and there we have the square root of 34. Now for a distance, the square root of 34 is not that useful. If you told someone that the store was square root of 34 feet away, they'd probably hit you in the face. So I'm going to actually plug this into the calculator and figure out what the approximate value of this is. So I'm going to switch my apps here. Here's our Canvas page. If you look on the left to the left sidebar here, you'll see the button for regular calculator. I'm going to go ahead and click that. And it pulls up a scientific calculator, which is actually through Desmos. So I'm going to say square root of 34. And that gives me 5.8309, etc., as you can see there. I'm going to round it to the third decimal place. So that'll be 5.831. And that would be my final answer. Note that in this case, the square root of 34 is actually considered the exact answer. There's no rounding that has occurred there. And the 5.831 is considered the approximate answer. So in this case, we wanted the approximate answer. So that's the distance formula. Now for the midpoint, this one I'm not going to derive for you today. I'm just going to write it down. The midpoint of 2 points x1, y1, oopsies, sorry about that, hit the home button, and x2, y2 is given by this formula, hk, where h is actually the average value of the x's, and k is the average value of the y's. So what this means is if we're trying to calculate the midpoint of the 2 points we looked at earlier, 2, 1, and -3, 4, all we would have to do is add the two x values, 2 plus -3, and divide by 2. And then also add the two y values, 1 plus 4, and then divide by 2. So if I'm going into my calculator here, which you don't really need to do on this problem, but it's worth showing again, if I do 2 plus -3 divided by 2. Notice this isn't actually what I want. It's only dividing the -3 by 2, so really what I need to do is put parentheses around the numerator, 2 plus -3, and then I can divide by 2. So I would get -0.5 here. And then 1 plus 4, I'm just going to do this one in my head, is 5 divided by 2 is 2.5. So then the midpoint is, the answer really to this problem is -0.5, 2.5. A nice way to double check is just to go back to the graph. So let me scroll up here. And double check that -0.5 and 2.5 looks to be roughly in the middle. So that's about -0.5 there. And then 2.5. Clearly I did not draw this very well. But if you were using graph paper, that looks pretty exact to me. It doesn't look like we made any glaring mistakes there. Now before I end this problem, we are done for this lesson. I've hit the goals was to find the distance and the midpoint. But I want to mention something about the calculator, and this is something I kind of glossed over, I also kind of mentioned, but whenever you have terms in the numerator, there's an implied set of parentheses around them. Please don't forget about that. As we saw when I went to the calculator, if I were to do 1 plus, sorry, let me delete all this. If I were to go 1 plus 4, oh, now I went to the square root of 34, having some technical difficulties. If I said 1 plus 4 and then I divide by 2, notice it only divides the 4 by 2. That's not good because 3 is not equal to 2.5. They're very close, but they're not equal. So please make sure that when you have implied parentheses, you tell the calculator about them. Your calculator is stupid. It doesn't really know what it's doing. So you have to actually give it the implied parentheses in order to get this. And that concludes our first video.